Thank you, sir. You can start the session now.
Yes, yes, sure, sir. Good morning, everyone. My topic is role of machine learning in IoT. So I would like to thank the organizers and my mentor, Dr. Jagadeesan sir, for giving me this opportunity to share my knowledge. So the outline of my presentation, I'm going to introduce IoT, and then I'm going to talk about the convergence of machine learning and IoT. Then I'm going to give the taxonomy of machine learning techniques, machine learning algorithms for IoT. Then the scope of machine learning algorithms in IoT. And finally, I'm going to highlight some of the research directions for future. So the Internet of Things, I hope all are familiar with this concept, IoT. So it is going to be the network of physical objects. It's a network of everyday objects that describes the physical objects with the sensors. So the physical everyday objects are equipped with the sensors and the actuators. They are embedded with the processing capability. They are embedded with the other technologies so that it will connect with the other devices for exchanging the data over the internet or some other network, private network. So the characteristics of IoT includes we can connect any device, any object. So I'm talking about the physical object, everyday object like table, fan, chair, window, door. So everything can be connected to the internet at any time, at any context. So anyone can access the device, anyone can access the data which are coming from the device. You can use any connectivity, you can use any network to communicate the data, to control the device from the remote, especially from the remote location. So the goal of our IoT is to bring the automation. So it is going to remove the human in the loop with very less intervention, or without human in the loop, we are going to do some task. So the important property of IoT is connectivity. That is the important requirement for your IoT infrastructure. So anyone, anywhere, at any time can connect. And this connectivity should be guaranteed at all the times. And one more thing is the identity of things. So each and every object or each and every device in the network are identified with a unique ID. For example, IP address can be mapped for all the devices or the nodes which are connected in the network. And all the devices, why we are connecting these devices means we are going to gather some data. So they are deployed over the terrain. They are deployed in the environment. It is going to observe some events. It is going to observe the happenings. It is going to observe the environmental and physical parameters. So we are going to gather the data. And with the help of the internet, we are going to share the data with each other. So it is going to share with other devices as well as it is going to share with the humans also. And one more thing is we can add some intelligence to IoT. Smart sensors, instead of traditional sensors, we can have a smart sensor devices to share the data, interact with the humans as well as with the other devices. Only thing is we need to have an updated software and latest firmware for all the devices and the nodes in the network. So these are some of the characteristics of your IoT. So it is, yeah, this is the history of IoT. So before the internet, we used to have a communication with the other person, human-to-human communication through fixed telephone. Then we used to send the text messages over the cellular communication. Then comes the Internet of Content, where you used to share the content information with the help of a www. So we are going to exchange the data with the help of email. We are going to exchange some media files. And slowly, then we moved to Internet of Services. So that is Web 2.0, where we had the e-commerce and e-productivity. We have the websites like when we have the IT platforms and the services with the Internet of Contents, we get the Internet of Services. Then comes the Internet of People, where we have social media networks like Facebook, Twitter, Instagram, where we connect with the various friends and the family members, and we used to share the data. Then comes the IoT, where machine-to-machine communication, device-to-device communication. So apart from human-to-human communication, we can communicate with the device also. Device can send the data to device, and device can send the data to the humans. So we can monitor anything over the planet with the help of sensors and the actuators. We can track the events, we can observe the events, we can bring the automation. So many stuffs we can do with the help of Internet of Things. So this is the history of Internet. So when you're talking about the number of connected devices, so the number of connected devices are in the worldwide now exceeds 17 billion actually with the number of IoT devices. So I'm talking about IoT devices with active devices connected to the internet. So the IoT devices, which is estimated around 7 billion devices, that does not include the smartphone, does not include the laptop, your PCs and other smart devices. So this is the estimation taken from IoTanalytics.com. So it is estimated that we are going to cross 34 billion devices, which includes both IoT and non-IoT devices by the year 2025. So why I am telling here is, so more than 34 billion devices are going to be connected to the internet. So they are going to share the data, and they are going to, some of the devices are going to generate the data, and it is going to share the data to it is going to store the data into the internet, and it is going to share the data to the other device of the humans. So you can imagine how much data will be stored over the internet worldwide. So we need a sufficient, sufficient resources to store the data and for processing the data and for identifying the events and for taking the decision. So we need some resources in order to store the data. That's why we are going to cloud. We need to have more processing capability. We need to have intelligent things to take a decision on the data. So when the number of devices increases, the more number of data are generated and more number of data are stored over the World Wide Web. So this graph shows the number of devices connected to the internet per person. So by the year 2025, per person, there will be more than 9 devices connected to the internet. So for example, we used to have a mobile phone that is always connected to the internet. So it is counted as one. We used to have a laptop that is always connected to the internet. Then we have a PC. Then we have a smart refrigerator. Then we have a smart TV. So like that. So internet connected devices, number of internet connected devices per person is going to cross 9 by the year 2025. So when the devices are connected to the internet, it is going to share the data over the internet with the other device or with the person. So machine to machine communication will happen, and person to person communication will happen. Device to person communication will happen over the internet. So the number of connected devices is going to cross 9 per person by the year 2025. So these are all the IoT enabling technologies. So in order to have the IoT system, IoT ecosystem, you need a sensor networks. So the fundamental unit of your IoT is a sensor and actuator network. So without the sensor network, you cannot have an IoT system. As I said earlier, those sensors are going to generate the data. It is going to observe the events. It is going to observe the happenings over the environment. It is going to observe the physical and environmental parameters. It is going to generate the data. So we need resources to store the data. We need resources to process the data. So We are moving for cloud computing, since it is going to generate the big data. Huge volume of data are generated. So we need a cloud computing technology to store the data. So what we are going to do with this data? For example, we are from the environmental monitoring system, we are going to get the temperature, we are going to get the humidity value. So out of these values, what we are going to do? So we may find a pattern out of it. We may forecast. We may go for prediction of weather for the upcoming days. So we need some algorithm or some technique in order to perform pre-processing, in order to do data analytics. So that's why we are going for machine learning. So we need to extract something from the data. So the data are coming from the sensor, and it is stored over the cloud, or it is stored somewhere in the World Wide Web. It is going to generate, the sensors are going to generate the big data. So after the data generation, what we are going to do? So we are going to extract something from the data. So we are going to extract some meaning out of the data. We are going to extract, we are going to reason on the data. We are going to deduce something from the data with the help of machine learning algorithms. So after reducing, after reasoning over the data, what we are going to do? We are going to take some decision on the data. Okay, so that's why we are going for machine learning for IoT. So these are all the enabling technologies for IoT system. We want sensor networks, because we are going to embed the sensors with the physical objects. We need a cloud computing, because the sensor network is going to generate a huge volume of data. So it may be it may be a periodic monitoring, or it may be a continuous monitoring. So irrespective of monitoring, it is going to generate more amount of data. So we need some resources to store the data, big data. And for processing the big data, we need some technique, that is a machine learning technique. So after processing, we are going to take a decision on the data. So these are all some of the IoT enabling technologies. So according to the father of pervasive computing, Mark Weiser, he stated around the 1990s, he stated like the most profound technologies are those that disappear. They weave themselves into the fabric of our everyday life until they are indistinguishable from it. Which means that the existing technologies are going to disappear in future. Disappear in the sense it is going to be the part of our life. Invisible computing. Okay, so he stated this statement in the year 1991 exactly in his seminar paper, American Scientific Journal, I think. So in 1991, he stated like that. So the existing technologies are those that disappear in future. They weave themselves into the fabric of our everyday life. So it will become a part and parcel of everyday life, and it will be an invisible computing. So out of this statement, now we are having the IoT. So it is the most prevalent and rising technologies in the current era. So the success of the emergence of IoT has been possible due to the advancement in the technologies in various fields, like in the digital electronics. We have MEMS technology, we have various communication technology, we have various internet protocols, we have various computing systems. So due to this advancement, we have IoT now everyday life. As I said earlier, IoT is going to generate the data. So with the help of sensors, it is going to generate the data. So in order to give a better services to the user. So why we are going for IoT? So we are going to make the life comfortable for the users, and we want to bring the automation. So everybody is talking about smartness. So everybody, all the governments worldwide, all the governments are looking up with the development of smart city, looking up with the development of a smart traffic system. So all are talking about the smartness. So which means that they are going to give a better services to the occupants or to the citizens, to the users. So we want the data to be processed in an efficient way, so that we are going to give a better services to the users or the occupants. So the IoT system, IoT based system should be capable of accessing the raw data from the different sources, data sources. Then after getting the raw data, we need to process the data and we need to extract some knowledge out of it. So as I said earlier, so many devices are going to be connected to the internet. So it is going to generate enormous amount of data. So every day it is going to generate because we are going to have a continuous monitoring. So every day it is going to generate the data and it will be stored over the internet so that we can access from the remote location. So it's not like we need to present in the particular environment to monitor and to take a decision. Sometimes the human involvement, little human involvement is required. So from remote location also we can access the data and we can take a decision on the data. So the volume of data which are generated from the IoT devices, especially from the sensors, is going to be very huge, and it is going to play a major role in terms of when we are talking about the better services, providing better services to the occupants or the user or to the citizens, the data which are coming from the sensors, from the IoT system, that is going to play a major role. So how we are going to provide the better services? So what are the things are required? So we are going to increase the prediction. I mean, enhance the prediction. We are going to improve the decision-making process. We are going to improve the accuracy. We are going to improve the efficiency of the process. We are going to improve. We are going to enhance the productivity. And as I said, we are going for IoT for automation. So we are going to bring the greater automation and we are going to increase the revenue wealth generation also. So for all these things, for all this process, we need the IoT data need to be analyzed in an efficient way so that we are going to extract the knowledge, meaning out of the data. So through different algorithms, so that is going, the data will be converted into information, then information will be converted into knowledge, then finally we are going to take action. So this process can be done with the help of different algorithms. So those algorithms are machine learning algorithms. So in order to provide better services to the citizens, better services to the occupants, we need to process the sensor data in an efficient way. So in order to process the sensor data in an efficient way, we are going for machine learning algorithms. So this is an pyramid which is familiar to everyone, I hope. So the data is a raw data. It's a fact. It may be a value which is coming from the sensors. Mostly these data are going to be the collection of raw facts or a value in an unorganized form. So with this data, you cannot draw some conclusion, which means it is going to mean a little for the machines or also for the humans. So we need to convert the data into some other form. So it is in an unorganized form. It will be a raw fact or it will be a raw value. So by looking at the data, we cannot conclude anything. So with the data, only with the raw data can mean very little. Okay, so we cannot conclude, we cannot extract any meaning out of the data. For example, if we get only the numeric like 35, we cannot say whether it is a numeric. We don't know whether it is a temperature value, whether we don't know it is a humidity value. We don't know anything. Just it is going to, the raw data will be like 35. So we don't know whether it is a weight or whether it may be a temperature or humidity or something like that. Okay, so we need to convert the data into information. So when we, so how to convert? So we need to add the contextual information, context. So we need to answer some questions. So who is responsible for the data? So what is, I mean, I'm talking about the data source. So if the data is coming from the temperature sensor, then it will be a temperature data. So 35 degrees Celsius or 35 degree Kelvin or 35 degrees Fahrenheit. So who is responsible for the data? So when you question who is responsible for this data and when it is generated, at what time the data is generated, where it is generated. Okay. So which means that when you're adding some metadata to the data, we are going to get the information. So you're going to have some structure like that is going to be easier to visualize, easier to measure, and easier to analyze also. So you're going to add data source information, and you're going to have some contextual information, which includes the time, temporal, and the spatial information. And then you're going to get the actually you're going to add some metadata to the data, raw data, then you're going to get the information. So when you're getting the information, it is easier to measure and easier to visualize and easier to analyze also. And you're going to do some pre-processing also, like you're going to clean some errors, you're going to remove some noises of raw data, which are present in the raw data. Then you're going to have, so then we need to convert into the knowledge. So in the knowledge, we are going to connect the pieces of information, how the pieces of information are connected. Okay, so so we are going to try a conclusion like how to apply this information to achieve a goal. For all the system, all the IoT systems, there will be an objective. So in order to achieve the objective, how these informations can be applied, how these informations can be applied to the system in order to achieve the objective. So we are going to connect all the information, connect each pieces of information to others, and it is going to help us to understand so how to apply this information in order to achieve the goal of IoT system. So that is going to give you the knowledge. And finally, we are having the wisdom. So the knowledge is applied in action, in terms of action. So why do something? So out of the data, we are going to perform some action. So why we are collecting the data? We are going to perform some action out of it. So that's why we are collecting the data. So we need to convert the data into knowledge. Then finally, we are going to take some action out of it. That is called wisdom. That is an actionable knowledge. Okay, that is called wisdom. So knowledge is applied in terms of action. So with the help of actuator, with the help of some device in the IoT system, we are going to perform the action. So from data, you are going to perform some action. So for performing action, you are going to convert some form to other form. Okay, so this is the knowledge from it. So with respect to IoT context. So same thing. So we are going to extract the hidden knowledge from the information in order to have a better understanding. So not only humans, machine has to extract some knowledge out of this data with the help of some algorithm so that the action can be taken. So this wisdom, actionable knowledge can be incorporated into some services, some products in order to have automation. So the automatic realization of this knowledge from me is the key point for the success of your IoT. So we are going to have automation. That automation is going to depend on the data converted into knowledge. So this knowledge pyramid is going to play a major role in the automatic realization. So that is done with the help of your algorithm, machine learning algorithm. So we need to do the proper analytics of huge amount of data which are coming from the IoT because it is very crucial. The huge amount of data is very crucial for the success of your IoT application. But it is very difficult to process the IoT data. Why? Because if you go for a real-time application, almost 20 to 30% of data are erroneous data. Sometimes it may be faulty data. Sometimes it may be data loss. Because we are going to use a wireless communication, we are not going to depend on the wired communication. Sometimes we are going for battlefield monitoring. Sometimes we are going for dense forest monitoring, wildlife habitat monitoring. So it's impossible to have a wired connection with all the devices. So when we are deploying the sensor nodes outside the outer environment, we used to get almost 20 to 30% of data quality. The erroneous data we used to get. So it's very difficult. It's a very challenging task to process the data with errors. Sometimes data loss will be there. Why? Because we are depending on the wireless technology, and we are going to deploy the nodes in the outdoor environment, and we are going to deploy the nodes in the dense forest region in the battlefield monitoring. So the environment is harsh environment. So we are going to face more data loss. So it will be a challenging task for the processing the IoT data, okay, which are generated from the sensors, IoT systems. So these are all the data properties of your IoT. So it will be a big data, and uh, yeah, one important property of your IoT data is redundancy. So we are going to deploy the sensor nodes in a redundant way. For example, if you want to monitor your temperature, we are going to deploy more number of temperature nodes in the same region. So there will be a correlation in order to spatial correlation. In the same location, for example, you want to monitor the temperature in your room. So you are going to deploy some 4 to 5 sensor nodes. So there will be a redundant data generation. Why? Because the sensor nodes are prone to failure. Okay. They are prone to generate erroneous data, and they are resource restricted devices. When you have only one sensor node, if it is not performing well, if it produces erroneous data, when you are taking the decision based on the erroneous data, so your reliability of your IoT application is going down. So that's why we are going to have a redundant deployment of sensor nodes for a single parameter. So it may be indoor environment or it may be outdoor environment. We are going to have a redundant deployment of sensor nodes in order to get a redundant information. Why? Because in order to tackle the data faults, in order to tackle the resource restriction. So sometimes the nodes may be in the, sometimes they may be in the selfish. Okay, they may be in the sleep state. Then their battery may drain out. Okay, so due to these reasons, we are going to have a redundant nodes in the same terrain in order to monitor the same parameter. And we need the data in a meaningful way. You know, for example, you're coding with some logic, like if a temperature is more than 35 degrees Celsius, you are going to do some task, like you are going to switch on something. Suppose if you are working in the nuclear power plant, if a temperature exceeds 300 degrees Fahrenheit, you need to cool up the heater, something like that. So the logic will be the temperature is more than 300 degrees Celsius, you need to cool down the plant. So that is a logic. So you are writing it. But you are getting the temperature sensor from various manufacturers. So they are going to use their own data sheets. So in the data sheets, for example, they may use a different units. When you are writing the logic with Celsius, by considering Celsius, 300 degrees Celsius, it may vary when you are using the different sensors. As I said, it will be redundant sensors. If we are getting the sensors from various manufacturers, they are going to use various data sheets. Some manufacturer will use unit Celsius, someone will follow Fahrenheit, someone will follow Kelvin. So there will be a ambiguity. So you need to have a semantic representation. You need to have a uniform representation, unified representation framework of a data, because you may get different. For example, the location coordinates may be represented in 2 coordinates with the help of 2 coordinates, longitude and latitude. Okay. Sometimes it may be represented with 3 coordinates also. In addition to that, you may have attitude also. So it may be represented in various ways. So you need to tackle with these problems also. So you need a unified representation of a data. So if you get the unified representation, uniform representation, then you can write a logic according to that, and you can take an action out of the data. And most of the data will be erroneous data. So you need to reconstruct the data before analyzing, or you need to ignore the data, because you are going to get redundant data. So for a single parameter, you're going to get the data from various sensors. So you're going to, one thing you're going to reconstruct with the help of spatial and temporal correlation. Sometimes you may consider attribute correlation also in order to reconstruct the data. So you may go for machine learning techniques for reconstruction. You may go for PCA or CCA techniques to reconstruct the data. You may go for any statistical. If it is a numeric data, you can go for statistical methods to reconstruct the data. Because most of the data will be erroneous data. You may face a data loss due to the wireless standards. You may have a noisy data. You may have a signal inference. So all these problems need to be considered when you are developing the IoT system and when you are taking the decision out of IoT data. Yeah, the rate of generation of data will be different for various devices, and that is also going to be a challenge for data processing. And the integration of sensor data. So sometimes you need to integrate the data for identifying a single event. For example, when you are identifying the fire event, you may get a data from different sensors, like you may get a data from temperature sensor, you may get a data from a smoke detector, you may get a data from a light sensor, you may get a data from the humidity sensor. So in order to identify a fire, you may integrate various like 4 sensor data in order to identify a single event. For example, I said you need to integrate temperature data with humidity, then integrate with the light sensor value, then integrate with the smoke detector value. Then finally, you are going to identify there will be, so there is a fire in this particular room or in the particular terrain. So you need, sometimes you need to integrate the various heterogeneous sources, not only homogeneous sources, you may integrate various heterogeneous sources data in order to identify the event. So that is going to pose a great challenge in the IoT data. And next is a smart data. So you are going to identify, you are going to have a different processing technique. You are going to have a data analysis technique in order to extract the knowledge out of the data. So the smart data can be a better substitute for IoT data capable of delivering the actionable knowledge and enhancing the decision-making process. So in order to increase the decision-making efficiency, you need a reliable data. So that reliable data is your smart data. So out of the data, you are going to extract the knowledge, and finally, you are going to take a decision. So for this transformation, so data science in general, the machine learning in particular is going to be the best option. Yeah, in order to get the smart data, so the data should be processed by various algorithms. So we are having different algorithms for different applications. So we need to identify which algorithm is suitable for which application. So we are having IoT will be deployed in various fields. It may be deployed in the city, it may be deployed over the smart home, it may be deployed in the outdoor environment. So we need to identify because we are having different algorithms. So we need to identify which algorithm is suitable for which application in order to extract the smart data for taking the better decision making process. So why? Because we are going to identify, we are going to discover the pattern, we are going to discover the hidden trends from the data, and we are going to predict the future data from the historical data, so that we are going to make the system smarter, more intelligent, and efficient for efficient decision making process. So we need to integrate the IoT system with various machine learning techniques, so that we need to bring the smart IoT system with more intelligent services and with more efficient decision making process. So that's why we need to have the convergence of IoT with ML. So the convergence of ML and IoT, it is a prospective advancement in efficiency, accuracy, productivity, and it is going to save the cost because we are going to deal with the resource restricted devices. So we need to save the resources, and we need to save the cost also. When the machine learning techniques and IoT uh, converges, then we are going to have an improved performance in communication, in computation, and we are going to have a better automation. We are going to have a better control over the environment, and there will be an improvement in decision making process also. So the machine learning algorithms face a better way to mine the huge volume of data which are coming from the IoT sensors, to have a to draw some meaningful conclusion of the IoT data. So we can use machine learning techniques. So in order to for a wide range of real-time application. So it allows us to make a critical in a time critical application or health related application. When you are taking a decision, that decision will be based on the data. So this machine learning algorithm is going to improve this decision making process, especially in the time critical application as well as in the uh, personal healthcare applications. So to solve the real world complex problem and to meet the computation and the communication requirement, for example, in the time critical application, you need to take a decision within the stipulated time. So you cannot take it may be a huge amount of data. You need to process the data within few seconds or the stipulated time, and you need to take a decision out of the data immediately. So in that scenario, you need to have a better computation technique, I mean, processing capability, and communication requirement is also important. So for this scenario, when you converge both machine learning techniques and IoT, it is going to improve the decision making process, and it is going to improve the overall efficiency for you. So with the machine learning, when you converge both machine learning and IoT, we can take up the data and transform the data into consistent format. As I said earlier, you need a unified data representation throughout the IoT systems. Now, sometimes an application area service will talk to the other service. Okay, so it's not like your device will communicate with the other device within the application. Sometimes the device may communicate with the device of other application for providing the better service. For example, in the smart home application, there will be a device called a thermostat. So before user arrival, it should switch on, and the water and the hot water will be ready for the user when he or she arrives home. So for this process, your device in the smart home will communicate with the traffic system, and it will predict when the user arrives home with respect to the current traffic condition. Okay, so there will be a communication with the different applications, like the smart home device will communicate with the smart traffic system. So when the two different applications are communicating or sharing the data, you need a uniform representation. You need a consistent format for data representation throughout the IoT ecosystem. So for that, we are going for semantic web representation as well as machine learning techniques. So with the help of machine learning with the IoT, you can generate the machine learning model, and you can deploy the machine learning model and various nodes on the cloud or top node and edge node to improve the overall performance. Yeah, now initially we discussed about IoT, then slowly we moved to IoT data. Then we discussed about the convergence of why we need to go for machine learning with IoT. Now, just an introduction about the machine learning. So it's a field of study that gives the computer the ability to learn without being explicitly programmed. So there are many definitions for machine learning. So this is one of the definitions. The field of study that gives a computer ability to learn without being explicitly programmed. So the fields of pattern recognition and computational learning theory actually lead to the evolution of machine learning. So initially, the machine learning algorithms were applied for very simple applications. So later on, they applied the machine learning techniques for various domains like computer vision, bioinformatics, um, spam and fraud detections, and biometric speech recognition, um, face recognition. So that they applied in almost in all the techniques um, in order to have a better process. So these are all the classification of various machine learning algorithms. So I have taken only two types, one is supervised learning and unsupervised learning. So this taxonomy is built especially for IoT. So I don't want to spend much time on this. So in the machine learning algorithms, we are having several types. So I'm going to take only two types, supervised and unsupervised learning. So in the supervised learning, it is going to take a known set of input data, and it is going to form a model to generate the reasonable prediction for the response to the new input data. So it is going to use a labeled data set to train the model or to train the algorithm to classify, to predict the result in an accurate way. So most of us are familiar with these supervised and unsupervised learning algorithms. So the goal of the supervised learning is to build a system that can learn the mapping between the input and output, and it may predict or it may classify the output of a system with the new input. So that is the goal of your supervised learning. Yeah, as I said, based on the nature of a training set, the learning algorithms are broadly classified into three groups: supervised, unsupervised, and reinforcement learning. So for this presentation, I have taken only supervised and unsupervised learning algorithms. The supervised learning, the sample of input vectors are trained and that are associated with the respective target vectors as a labels. So when you are dealing with no labels, that is coming under unsupervised learning. So when you are dealing with the reward and punishment for learning, it is going to be the reinforcement learning. Yeah, I'm not going to take much time on this. So directly we'll go to the algorithms. What are the algorithms which are used for IoT applications? So the first one is KNN algorithm. So it is the simplest machine learning algorithm. It is going to asking the similarity. It is going to find the similarity between the data. Uh, it is a lazy algorithm. We can say it is a lazy learner algorithm. Because why? Because it does not learn from the training data set immediately. Instead of that, it is going to store the data, at the time of classification or at the time of a process. It is going to perform the task on the data set. So during the training, it is going to store the data set. So it is a non-parametric algorithm, and it is going to find the k data points from the training data set, which are close enough to any data point. It is going to classify it. So there will be a distance metric or a similarity metric. So that is called k. So it is based on the distance or based on the similarity metric. It is going to classify the data points. So the scope of KNN in the IoT, as I said, it is very simple algorithm. So it is very easily implementable in IoT because IoT are going to be the resource restricted environment. And it is robust against the noises and the signal inferences. It is efficient with respect to time. So when it is a time critical application, you may go for KNN. And it does not work good with the large data sets, and it is going to consume more memory since we are dealing with the resource restricted devices. When we are dealing with a very large data set, the resultant will be it is going to consume more resources for classification and for other process. You can go for KNN when you are dealing with the personal healthcare application, when you are monitoring the physiological signals of humans for detecting the events, then you can go for KNN classifiers. And it is suitable for detection of errors, detection of outliers in the streaming data. Streaming data means continuous data you are going to get. So out of the continuous data, you can detect the outliers, you can detect the errors, especially which are coming from the sensors. And you can go for intrusion detection also. So the node may be faulty data, faulty node, or node may be compromised node. So those things can be easily detected, easily classified with the help of KNN. So the KNN is very easy to implement, and it's very simple one, and it will be good for healthcare applications when we are identifying the events, when we are classifying something which are related to the medical event. So this algorithm works very well, and it is efficient in detecting the errors as well as efficient in detecting the outliers. Next is Navy-based classifier. So it is based on the Bayes theorem for solving the classification problem. So it is a probabilistic classifier, which means it predicts on the basis of a probability of an object. It is very simple and the most effective classification algorithm, and also it's a very fast algorithm, which makes quick classification as well as prediction. So what do you mean by Navy? As well as the occurrence of certain event or certain feature is independent occurrence of other features. Okay. So next is a Bayes. So that is going to be based on the Bayes theorem. So the scope of this classifier will be, it is computationally efficient one. It works well with high dimensional data sets, and when you are training the algorithm with a small data set, also it will work for high data set, high dimensional data points. So this classifier is having a lot of scope in the smart data analysis and has proved the better model for various use cases, various scenarios like text categorization, spam filtering, and medical diagnosis classification. And also this classifier is used in security, IoT security, which is used to detect the intrusion detection. The next is linear regression. So it is a statistical method that is used for predictive analysis. So linear regression makes a prediction for continuous, real or numeric values. The algorithm shows it is going to generate the linear relationship between the dependent and one or more independent variable. It is going to use a metric like the Bayesian linear regression, or least mean square, or regularized least square, or ordinary least square to train the model and to minimize the cost function. So the value of how the value of an independent variable is changing according to the value of independent variable. So that we are going to get from the linear regression. So the scope of linear regression in IoT would be, it is widely used for predictive modeling, especially in the time series modeling. So when we are dealing with temporal data, so this algorithm is going to be the best one. So with the help of time series modeling and we can predict something which is faulty data in between. So we can consider the continuous data continuously. We are going to get the data if something is faulty. So with the help of time series, with the help of this algorithm, we can predict the future data, and you can compare the data, and you can minimize the loss function. And sometimes you need to reconstruct the data in order to take a better decision. You can reconstruct that faulty data also. So for reconstruction, you can go for this algorithm, linear regression algorithm. And this algorithm is going to be the best for anomaly detection, and it will be best for prediction of various parameters, especially in the smart domain environment. Next is SVM. It is a support vector machine. It is used for classification as well as various regression problems. Basically, it is used for classification problem. Primarily, it is used for classification problem. So the goal of the objective of this SVM is to create the baseline or boundary at, I mean, the decision boundary that can segregate the dimensional space into the various classes so that we can easily put the data points in the correct category. So the SVM chooses the extreme points or the vectors that helps in creating the boundary line, that is a hyperplane. So these extreme cases are called the support vector, hence the name support vector machine. So the scope of SVM in IoT is it is better placed in the number of applications which uses the classification of traffic data, image classification, text handwriting recognition, and in protein classification, especially in the healthcare environment, you can go for SVM for classifying the protein data. And the SVM can also be used in the smart home for developing a real-time tracking system, which uses the camera for detecting the human motion and detecting the various fall detection techniques. So it is best suited for real-time activity in the indoor environment like smart homes. So you can go for SVM when you are dealing with a smart home, and when you are dealing with a human activity recognition or fall detection, elderly people fall detection, or baby monitoring, you can go for SVM because it is best suited for healthcare application as well as in the medicine field. The next is a classification and regression tree CRT chart. So this algorithm explains how a target variable value can be predicted based on the other value. So it is a decision tree where each fork is predicted with the predicted variable, and each node at the end has prediction for the target variable. So the prediction of a label for the data points falling into the particular region is done by assigning a classification or regression model to the particular region. So the scope of this algorithm in the IoT domain is, so it is scalable to very large data set, and it is you can implement this algorithm in a faster way. If you have a irregular labeling of data, it is going to suffer much because it is going to be highly sensitive to the training data set. And when you are dealing with the behavior identification of occupants, this algorithm is best suited for this, classifying the smart citizen behavior. And there will be a pattern recognition of various person travels in the tourist spots. So for this application, this algorithm is suitable, like classifying the citizen behavior and finding the travel pattern in the tourist spots in the city or in the country. So this algorithm is going to be great applicability in smart citizen behavior, as well as when you're finding the travel pattern of transit riders in the particular city or in the particular country. And it is scalable to very large data set also. The next is a random forest algorithm. So it is a very powerful algorithm and a versatile machine learning algorithm that grows and combines multiple decision trees. So that's why we are getting the name forest. So it is used for both classification and regression, and it uses bagging and the feature randomness when we are building the each individual tree to create an uncorrelated forest. For classification tasks, the output of a random forest is the class selected by most of the trees in the forest. For the regression task, the mean or average prediction of an individual tree. So that So it is used to visualize the multidimensional data, and it is used to reduce the number of dimensions of the data. This BC algorithm can be used to resize various data, and it can visualize the image data. It can resize the image with very less information, providing the summary indices. The scope of this PCA in IoT domain is it is going to work well with the high dimensional data. So you are going to reduce the data size, and it is going to be when you are dealing with a very large data set, it is going to be resource consuming process. And this PCA is one of the important pre-processing technique in the machine learning world. And it is widely used to visualize the multidimensional data. And it is used to visualize the data in the real-time process. And it is used, this particular algorithm is used in various applications, which involves the fault detection. It may be a data fault detection, or it may be a node fault detection, and it is used to identify the data outliers also. The next is a CCA, canonical correlation analysis. So it is also a dimensionality detection technique, which is similar to PCA. So it is somewhat improved version of PCA because it is going to correlate two or more variables where we are going to have attribute correlation kind of thing. So this CCA is used to identify and measure the association among two or more set of variables. So it is a way of inferring the information by considering the covariances matrix. So the main purpose of this would be like to determine the correlation among various two or more variables. So the scope of CCA in IoT would be like it will be used in cybersecurity applications. And mainly since it is dealing with the data correlation, we can use this algorithm for detecting the data outliers. And some of the real-time application which are similar to PC algorithms. The PC algorithms are used for large data set, highly dimensional data set. So the same thing, these algorithms also best suited for high dimensional data sets. And you can use this algorithm for real-time applications, event tracking, identifying the patterns, identifying the travel patterns, identifying the behavior of a human. So you can apply in the neuroscience applications. You can apply the CCA algorithm in monitoring the public places, and you can apply this algorithm in cybersecurity. Yeah, next is a future research direction. So the convergence of IoT and the machine learning algorithms has created very enormous opportunities. So the machine learning based on the IoT data has matched the physical world and the cyber world together to have improved service, and investigating the real world challenges. Now to investigate the real world challenges, we need to integrate both the physical world and the cyber world. So there are some of the research directions when we are converging both the areas, like converging the machine learning and IoT together. So we need to have an improved cybersecurity, and we need to apply the machine learning at the edge of the node itself, and we need to have a better scalability, and we need to have a hyper-convergence. So these are all the 4 areas where we need to have a future research. So first one is improved cybersecurity. So in order to have the improved decision making, machine learning algorithms are heavily depending on the IoT data, which are transmitted from the IoT device. So the IoT layers, like we have different IoT architecture. We have 3-layer architecture. We have 4-layer architecture. So you may develop different levels of IoT. applications. We have 3-level application, 4-level application, 5-level application, 2-level application, and we have different layers in various architectures of IoT. So the data are coming from the different layers, and the data are represented in different formats, and all the data may be prone to various attacks, cyber attacks. Since all the data are going to be stored and processed over the cyber world, so they are vulnerable to the cyber attacks. For example, malicious code injection, node tampering. Physically, you can go to the node and you can tamper the node and you can inject the false data. The DOS attacks, routing attacks, data transmit attacks. So several attacks are possible when you are dealing with the IoT application. So you need to have improved cybersecurity because the data is going to play a major role. You are going to use the machine learning to extract the knowledge from the IoT data. So in order to protect the data, you need to have improved cybersecurity. And one thing is you can propose, you need to protect the node as well as you need to protect the data. So for this both protection, node level and the data level, you can go for a trust management, development of trust management framework for your IoT application in order to have an improved cybersecurity. The next is machine learning at the edge level of a node, edge level of a network. So the IoT time critical application, you may require a faster processing of data and the decision making should be done within the stipulated time. If it is a time critical application, you need to take a decision with the stipulated time. So when you are moving the data to the cloud and over the cloud, you are going to process and you are going to take a decision over the cloud and it is going to be sent back to the IoT environment. So this process is going to take some time. It may be a second or it may be a millisecond. Obviously, when you are transferring the data to the cloud, all the data to the cloud, we need to pre-process the data and we need to analyze the data and finally we need to take a decision. And the decision should be sent to the IoT environment for taking the action. So sending the data to the cloud and processing the data and taking the decision requires more time and it is going to consume more resources also. When you are dealing with the time critical application, latency, you need to deal with the delay. Okay, so within the stipulated time, you need to take a decision. So you can apply the machine learning techniques, some of the machine learning techniques at the edge of the network itself. So instead of transferring all the data to the cloud or all the data to the server, you can employ some of the machine learning techniques at the edge of the node itself in order to have a time critical decision making. Scalability. So the scalability, so it's an ability of a system to grow without affecting the performance. So when you are adding more number of hardware, or when you're adding more number of nodes in the network, or when you are adding the software and the middleware to the existing system, the performance should not affect. So that is scalability. So when the critical application, when the user wants to, when the end user requires a big number of interconnection, your system, IoT system should support. And the number of connected devices and the number of connected services may increase at any time. It is dynamic in nature. So when you are increasing the number of nodes or the number of services, your performance should not go down. Okay. So that is scalability. And hyperconvergence, so it is a IT framework that combines the various services like storage, computing, networking into a single system. So this convergence setting, hyperconvergence setting, storage facilities, some of the resources will be shared among various nodes in the IoT framework, and this is going to be a challenge when you are sharing the resources among the heterogeneous network. Is going to be a challenging task because you are going to combine the various resources like storage, computational power, and networking units. Okay, so when you are converging several resources and when you are sharing the resources for the when you are distributing these resources as a single system for heterogeneous nodes in the IoT ecosystem, it's a really a tough task. So some of the questions you need to answer when you are dealing with the hyper convergence, like how a new node can be added to the existing community network in the presence of faults. And so there is a need to examine how large amount of data can be shared across storage nodes such as data centers. And there is a need to design the intelligent solutions for the hyperconvergent settings. So these are some of the future research directions. And heterogeneous nature of IoT. So as I said earlier, the nodes and the ecosystem itself heterogeneous because we are going to have heterogeneous nodes, heterogeneous systems over the IoT ecosystem. And the IoT is going to produce a very big data, and all the data are not going to be a valid data. So we need to take a decision on that whether we need to process all the data or only we need to remove the erroneous data or unreliable data. So we need to decide on that. So is it worthwhile to process all of it because the data set is going to have an invalid data also. And the node can be compromised at any time in the IoT system. So is it worthwhile to consider the compromised data which are coming from the compromised node? So it is also a research question. There are some critical questions shaping the reliability, accuracy, and the efficiency of machine learning algorithms for IoT domain. So we need to address these questions, whether we need to consider all the data or we need to ignore some of the faulty data, some of the erroneous data before applying to the machine learning algorithms, or we need to consider all the data. Sometimes a compromised node can generate the reliable data. Sometimes it may generate the unreliable data. So we need to take a decision whether we should consider the compromised nodes data also when you are applying the data set for the machine learning algorithm. So we need to decide on that. And the sensing devices are not always accurate and reliable because they are depending on the various resources. With the batteries down, for example, if the battery power is going down from 5% means it is highly probable that the particular node is going to generate the erroneous data. So the sending devices are not always accurate and not always reliable. So we need to consider that also. And every application has data with a particular properties. So we need to consider all the application by considering all the properties. So these are all some of the research future research directions you need to consider when you are talking about the convergence of ML and IoT. So these are all the references. So all the data, all the facts and all the figures are taken from these research papers. So I'm not having any copyright on that. Thank you. So if you have any queries, so you can post the queries.
So dear participant, do you have any query? Please ask to Karthik sir here.
No queries, sir. Thank you.
So I will post our feedback link today, morning link. So dear participant, today is one more section there, the evening section 6 to 7:30. Already postponed one section. We are going to handle the 6 to 7:30. So I ask to everyone to please join the 6 to 7:30. Karthik sir.
Yes, sir.
Thank you very much for your valuable speech.
Yes, sir. Thank you, sir. Thank you for giving me the opportunity to share some knowledge. Thank you, everyone, for listening to this lecture. Thank you, sir. Thank you.
Thank you very much.
Yeah, thank you, sir. Thank you.